Dear students, welcome to s.mathguru classes. So our main discussion is Charpit's equation of first order linear partial differential equation. So we solved some problems. Now we consider the remaining problems. Charpit's equation is very easy, very simple. We can solve the problems easily. Solved by using the Charpit's method. p²+qy equal to z. This one given. Now solution: f x y z pq equal to 0 is p²+qy minus z equal to 0. That is, f equal to we get p²+qy minus z equal to 0. First we find del f del x. Del x p²+qy minus z, this we consider, and this will be 0 0 minus 0. This family is 0 because we differentiate partially with respect to x is absent, so all of these are 0. Del f del y, this is del y p²+qy minus z. This is 0, this is q into 1 minus 0, this equal to q. Del f del z, this is del z f, this is p²+qy minus z, this equal to 0 0 minus 1, this is minus 1. Next, del f del p, this equal to del p, this is p²+qy minus z, this is twice p plus 0 minus 0, this is twice p. Del f del q, this is del q p²+qy minus z, this equal to 0 plus y into 1 minus 0, this is y. We get this one. Now according to Charpit's equations, we have dx by del f minus del f del p, dy by minus del f del q, dz by minus p del f del p minus q del f del q, dp by, this is p del f del p minus del f q del f del q, and dp by del f del x plus p del f del z, dq by del f del y plus q del f del z, d phi by 0. We get, this is our Charpit's equation. Charpit's equation is this one. Now putting the ready-made values, this will be dx by minus del f del p is twice p, dy del f del q, this is y minus y, dz minus p del f del p means twice p, minus q del f del q this is y, and dp by del f del x, this is 0, plus p into del f del z, this one minus 1. This equal to dq by del f del y. Del f del y is q, plus q del f del z is minus 1. Minus 1, this equal to d phi by 0. We get this one. Now we get this is dx by minus twice p, dy by minus y, dz by minus 2p square plus qy. If we taking minus sign common, dp by minus p, dz dq by 0, p minus q 0, and d phi by 0. Multiplying both sides by minus sign, then dx by twice p, dy by y, dz by 2p square plus qy, dp by p, dq by 0, this d phi by 0. So we consider one simplest form from these equations. Now if we consider dp by p dq by 0, then this implies dq equal to 0. So if we integrate this, then dq, this is q equal to a, we get q equal to a. So a is a constant, and putting this value of q here, since p square plus qy equal to z, p square plus q means a, ay equal to z, and p square equal to z minus ay. This implies p equal to root over z minus ay. So we get this is our p. Since dz equal to p dx plus q dy, this is our dz, and this implies dz equal to p means we know the value of p, just we get p root over z minus ay dx, and q means a dy. This is dz minus a dy equal to z minus ay dx. This implies dz minus a dy divided by root over z minus ay equal to dx. We get this. If we integrate on both sides, after separating, if we integrate both sides, we know this formula, integration f dash x by root over fx dx, this equal to 2 times of root over fx plus c. We know this formula. Integration f dash x by root over fx dx equal to 2 times of root over fx plus c, that 2 times of root denominator. If differentiation of denominator, this fx, the dx of fx means f dash x, if differentiation of this given here, answer 2 times of denominator. If we differentiate this, then we get dz a dy, that means differentiation of this given in numerator, so we get 2 times of denominator, and integration dx means x plus, we get this one. If we squaring both sides, then we get 4 z minus ay root over will be cancelled. This is x plus b whole square, and this is z minus ay x plus b whole square by 4. This implies z equal to ay plus x plus b whole square by 4. So this is the answer, or we can expand this one also. This is the final answer. Very easy solution, very nice and very important also for any engineering courses. Thank you.